In this lecture, we will study about modes of heat transfer and effect of painting on power transformer. So, we have seen last lecture how the cooling is very important in a power transformer, how the temperature will affect the aging of the power transformer. So, therefore, cooling assumes importance due to the reason that temperature is the only culprit which will reduce the life of a power transformer. This is operating time versus hot spot temperature, just an extension to our previous study on importance of temperature. So you can see here for 1 day loss of life, the characteristic is for 1 day loss of life. What is the operating duration for a given hot spot temperature? For example, to understand this graph, at 98 degrees centigrade, 24 hours is the duration for which we have to run the transformer in order to have 1 day loss of life. Means 98 degrees centigrade hot spot temperature corresponds to 1 day loss for 1 day operation. Means actual time of operation is equal to its loss of life. That is what at 98 degrees centigrade. But it doesn't happen the same way if operated at higher temperature. For example, 110, 130 degrees centigrade, if we operate the transformer, within 2 hours, 1 day life is lost. So 1 day life is referred to here as 98 degrees centigrade if operated at 24 hours, then it is 1 day loss. So actual life is at 98 degrees centigrade operation. So how to calculate, how to obtain this curve? This curve is very simple actually. We have Bloom's law, right? With Bloom's law, the aging units A equals to T into e to the power of NT, where capital T is temperature, small t is time. So at 24 hours of operation at T is equal to 98 degrees centigrade, we can obtain A value. For example, A equals to actually 24 into e to the power of n into 98 degrees centigrade. Right. So this will give a value of A. So with this value of A, you can easily obtain the general characteristics. This is some constant A, say. So therefore, T equals to A into e to the power of minus NT. So this is how. So for any duration T, so for a particular temperature T, it is the characteristic is exponentially decaying characteristics. So that's how this characteristic is obtained actually. So you can see it for higher temperatures 130, 140 degrees centigrade. So 2 hour operation is enough for a transformer to lose 1 day loss of life at normal temperature, that is 98 degrees centigrade. So next these two graphs are of importance. One is this is from Bloom et al. And then the next one is Bernard Hochart. Okay, so these two graphs indicate more or less same characteristic only. So here you can see this is percentage load is given here, 75%, 100% and 140%, and then this is the ambient temperature. So ambient temperature decreases the capability of the transformer actually, ultimate operating temperature. So for example, at 0 degrees centigrade, we can operate the transformer at 140% of load compared to normal load. So at 30 degrees centigrade, roughly ambient temperature of 30 degrees corresponds to 100% operation. and then 75% you can see at 50 degrees centigrade, so and so. It decreases with temperature in general. It decreases with ambient temperature, so atmospheric temperature. So similar characteristic, in terms of power in continuous supply is given here. This is 120, 100 and 82. So it decreases with 0 degree centigrade. This is 120 units, and then it decreases with ambient temperature. So in general, these two characteristics, of course, look a little bit different. One is exponentially, parabolically decreasing. Other one is decreasing like a straight line. But the decreasing trend is correct actually. So with ambient temperature, as the temperature of ambient increases, the load capability, alternating load capability or kVA capability decreases. So this is also an important characteristics. The next one is effect of altitude on temperature rise. So altitude means, height of the place. So as you all know, if we, the percentage temperature rises, percentage hotspot temperature rises with increase in the height above the ground. So altitude also causes increase in hotspot temperature, and it is more or less straight line characteristics are shown here. So these characteristics throw importance of cooling in a transformer. Therefore, modes of heat transformer, heat transfer in transformer are very important. So here, conduction, convection, and radiation, these three are normal, heat transfer modes. So of course, all three will be there in every system, but which are important, which are more important, which are least important is given here. Conduction plays least role, and convection plays most important role. So radiation is in between actually. So these are the basic modes of heat transfer in a transformer. So now let us see where conduction comes into picture and where. So what is conduction? First of all, heat loss by conduction depends on the following formula: W is equal to T, where T is the temperature difference between two ends of the material. For example, if there is a material like this, and then from here this end to this end, if heat were to move like this, then the temperature difference T between these two terminals, these two surfaces, and then this is the length of the path, and then thermal resistivity of the material. So this is thermal resistance of the material. Then WCD equals to T by L into R. So this is how, just like similar to our electrical quantities, analogous quantities can be thought here. So the temperature corresponds to potential, and then heat corresponds to current. So like that, if you do, you can obtain an analogy between heat flow and our electrical circuit. So this is about conduction, but where this conduction will occur inside the transformer is of importance for us. So in a transformer, the heat must pass from the conductors and core iron through the insulation, oil and the steel case and the paint coating finally. So and then to the environment. So if we consider the thickness of the paint, it will be very small actually. This is infinitesimal amount of the thickness. Therefore, the color on conduction, color of paint on conduction is negligible. And conduction you see mainly from windings and then core to the oil. And in oil, through convection majority of the heat will be transferred actually, not through conduction. So this is the role of the conduction, and let us see what is convection. Convection, heat loss by convection depends on the shape and size of the transformer and the temperature and the rate of movement of the cooling medium. The type and color of the paint have no effect on convection. Convection it takes place inside the tank actually. Even majority of the conduction also takes place inside the tank actually. So this is the transformer, and here the oil will be there. So here the oil will be there. These are windings. So here, most of the, conduction process will take place within the core, these windings, core, and then that will be transferred to the oil. And in oil, it will be through convection, and from convection outer tank again small conduction will be there, and then outer surface radiation will be there, or cooling mechanism and all. So the type and color of the paint have no effect on the convection. And then finally the radiation. Radiation is where it will occur actually. Radiation will be on the outer surface of tank actually. Basically, radiation occurs on the surface, and outer surface is very important for radiation. So here you can see, it was mathematically proved that the area effective for radiation is the outside envelope of a surface, irrespective of its shape. What is the total area? That matters actually. And the radiation is given by this formula, epsilon sigma T2 to the power of 4 minus T1 to the power of 4 watts per square meters, where epsilon is emissivity factor. It is 1 for black body, 0 for polished silver. So, and sigma value is 5.67 into 10 to the power of minus 8 into watts per meter square per Kelvin to the power of 4. Sigma is known as Stefan-Boltzmann constant, and emissivity of the most of the paints used in practice is 0.9 to 0.95. These paints are non-metallic paints I am talking about here. For non-metallic paints, the emissivity is in this order. So, here what is the problem we have to understand here? There is a difference in transformers kept under shade and kept under sunlight. So, it means that indoor transformer and outdoor transformer, the radiation property is a little bit different. This is very important to understand. That's why this separate lecture is devised for that. Color of the tank. So, as radiation plays dominant role in cooling of plain tanks. Plain tanks means, which do not have radiators, which do not have external cooling mechanisms such as fans, coolers, etc. For those plain tanks, color of the outermost paint layer plays a role. Where it plays a role and how it plays a role, let us see. In shade means indoor transformer, kept inside a room or inside a roof enclosure, where the temperature rise of a transformer tank painted with non-metallic paint is practically independent of the color. So, all non-metallic paints actually have very good radiation property when they are in shade. In shade means in indoor transformer. But metallic paints radiate less than non-metallic paints and may cause overheating. This is the problem. Normally, we think that metals may radiate, by, general perception of the people. Metals may radiate, more amount of heat. No, they reflect more amount of the heat. If you keep in sunlight, metallic paint will be better actually. Metallic paints reflect but not radiate. Radiation property is very poor for them actually. So, but non-metallic paints will radiate very effectively. A small amount of aluminum powder is mixed into the paint. That is what is metallic paint actually. Normally, aluminum powder is mixed. The metal particles pick up and reflect the light, and hence they will actually shine. That's what, even vehicles, cars, etc. are they use metallic paints only. The glitter, that shine that comes due to the reflection of the light. With radiators and tubes, the effect of metallic paint in increasing the temperature rise becomes less and less, and in extreme case as low as 7%. This means that if we use radiators and tubes, so metallic paints, of course they cause overheating, but their overheating can be ignored, and it may be as low as 7% if we use these radiators and tubes. So the paint effect will go. So that's what, for plain tanks, it is important. For, if you have radiators, coolers, etc., then paint effect can be ignored. Paint effect comes into picture for plain tanks only, and in the plain tanks, if you keep under shade, means for indoor transformer, so non-metallic paint is better actually. They will radiate better actually, and metallic paints are not good for indoor transformers. So then, this is what is this. As there is no reflection of the sun rays to be considered with transformers located indoors, the type and color of the paint will affect only heat loss by the radiation. So, as there is no reflection of the sun rays to be considered with the transformers located indoors, the type and color of paint will affect only heat loss by radiation. So then an aluminum painted transformer would be expected to operate at a higher temperature than one painted in black or any other color due to the low emissivity factor of the aluminum paint. So this is what is important actually. Aluminum paint emissivity factor, that emissivity coefficient is very less, but non-metallic paints, they have emissivity in the order of 0.95. These values are also given here. The value of epsilon for aluminum paint is just 0.55, and for black paint it is 0.95, and for practically any other paint means that any other non-metallic paint, it is in the order of 0.9 to 0.95. Therefore, they are good enough in indoor transformers. An aluminum painted transformer will therefore dissipate radiation approximately 1/3 less heat than a transformer painted in some other color. That's what, metallic paints, it's a wrong perception normally that exists, that they will emit or radiate the heat energy better than these non-metallic paints. But it is not so. We have to be careful in choosing the color of these plain tanks. And color of the tanks for outdoor transformer. What is good for a outdoor transformer? In sunshine, improvements resulting from the use of special paints is insignificant. Okay, sunshine is so much that the improvements obtained these special paints means that non-metallic paints is insignificant, because their reflection of the heat is important. Therefore, metallic paint will work better in sunshine. Painting must be from the consideration of durability, appearance rather than heating consideration. Of course, this is one consideration. Temperature drop in the old coats or coats of paints is generally negligible. So, of course, but here the metallic paints actually work better because they reflect the sunshine. Of course, the effect may be, of insignificant order. let us see. But outdoor transformer, when transformers are located in sun, both absorption of solar heat and radiation of transformer heat must be considered. Both should be considered. See, one way, the black body absorbs the heat better, but it also radiates the better way. So, therefore, if it is in shade where there is no scope for absorption, better radiation is required. Therefore, black paint or the non-metallic paint will be used. That will be better. But in sunlight, there will be solar sun rays actually. The solar heat will be absorbed there. Then if the absorption is more, like if we use black body, then the heat absorption may be more, and then they may heat up actually. So therefore, although better radiation is possible with black paints, metallic paints, since metallic paints reflect well the sunlight, then therefore it is better to use metallic paints only. Unfortunately, the colors that give best radiation of transformer heat will permit the highest absorption of the heat from the direct rays of the sun. That is the problem. The coefficient of absorption of solar radiation are as follows. White, lead paint coating 0.25 and light cream paint coating 0.35, aluminum paint coating again 0.55, but black paint you can see 0.97. So, like this. Therefore, for outdoor transformers, so it should be less only, absorption should be less only. Therefore, aluminum or metal coatings work better. Then, as a summary, indoor transformers should not be painted with metallic paints, since other paints will have satisfactory lasting qualities when protected from the weather and will result in a cooler transformer. Any color that fits color scheme can be used. And self-cooled transformers exposed to sun should be painted in aluminum only, where means metallic paint only, where operating temperatures are critical. Other colors are preferable from the appearance standpoint and should fit into an established color scheme. Water-cooled or forced oil-cooled transformers can be painted any color that fits the color scheme or general surroundings, because the moment your cooling system is there, it's not a plain transformer. Therefore, the color effects will become insignificant, because special radiation through radiation will be not radiation, actually air fans can be used and coolers can be used. So maybe additional convection etc. will dominate. So therefore, this effect can be neglected. Environmentally, such color scheme should be chosen for exterior items which are visible to the public, etc. So these are the details or important information about coloring of a transformer.